Okay, number 5, rewrite using rational exponent notation. We want to remember that a rational exponent is just an exponent that is a fraction. So what fraction corresponds to the cube root is just 1/3. Here, the fourth root is just going to be 1/4. So if we had x to the third to the 1/4 power, we would multiply these powers and get x to the 3/4. So rewrite using radical notation. Well, now we have -7 to the 4th, because that's the numerator. The denominator is kind of hard to see on this, but you can see in your packet it's a 3. So that's going to be the cube root. Here, we've got a numerator of 2, which means it's going to be x squared, and a denominator of 5. So that's going to be the 5th root. I always recommend doing the root outside. It's kind of up to you, though. All right, evaluate. 1/2 as a power is like the square root. So the square root of 9 is 3. And for 81, I can either cube it first, or I can take the 4th root first, because the numerator is a 3 and the denominator is a 4. I think it's way easier to take the 4th root of 81. So what number multiplied 3 times gives you 81? Well, that number would be 3. So now I'm going to have 3 cubed. 3 cubed is 27. So I have 3 times 27 gives me 81. B, I have 27 to the negative 2/3. So I'm going to rewrite that completely. So the negative makes it 1/. The 3 is a cube root, and the 2 is a square. Now, I know that the cube root of 27 is 3, so I'm actually going to put the square outside and take the cube root first. So that would give me 1/3 squared. 1/3 squared is 1/9. All right. Letter C. When I get to letter C, I immediately see I have powers raised to powers, and there's a negative sign. So the first thing I'm going to do, carve out a little box here, is I'm going to get rid of this negative and flip it over. So I'm going to have 7 to the 4th over 3 to the 4th to the positive 1/4 power. Okay, got rid of the negative by flipping my fraction. When I raise a power to another power, I multiply the powers. Well, 4 times 1/4 is just 1. So my final answer is going to be 7/3. Letter D. The first thing I can do, I have common bases 2 and 2, so 1/5 and 1/2 can be added. If I add 1/5 and 1/2, I get 7/10. So D, I've got 2 to the 7/10. Inside the parentheses, raised to the 10th power. Well, when I raise a power to another power, I'm going to multiply. Here I added the powers again. And that would just give me 2 to the 7th. I would leave it 2 to the 7th. If you want to rewrite it as 128, you can. Number 8, simplify each of the following. Assume all variables are positive. Now, once again, we are just going to apply our monomial exponent properties. When I raise a power to another power, I multiply. 1/3 times 12 gives us a to the 4th. 3/4 times 12 would give us b to the 9th. Letter B. This one's a little trickier. I've got 4x to the negative 2/3 times 6x to the negative 1/6. Well, the first thing I'm going to do is just multiply my coefficients. That would give me 24. The next thing I'm going to do is add my powers because I have common bases. I'm going to make this into negative 4/6. That way I have common denominators, and that gives me negative 5/6. Well, because I have a negative there, I really don't want a negative exponent. I'm going to rewrite this now as 24 over x to the 5/6. It's terrible looking. Letter C. Here we're going to subtract the powers. So 3/5 minus 2/3 is 1/15. So that would be x to the, negative 1/15. So we really want to write that as 1 over x to the 1. Letter D. I want to be really careful here. I have a lot of different variables. First, I'm going to look at the a's. I have 2/3 minus negative 1/3. Well, because it's subtraction, that's going to turn this into a positive. 2/3 minus negative 1/3 is 3/3. 3/3 is just 1. Now I have b to the first minus negative 2 becomes b to the third. Now I've got negative 3/4 minus 7/4 would be negative 4/4, which is just negative 1, which means the c is going to be in the denominator. Letter E. I have x to the 5th raised to the 3/10. When I have a power raised to another power, I multiply those powers. So that would be 15/10. 15/10 reduces to 5/2. Letter F. The 4th root of 81, I know, is 3. The 4th root of 4, the 4th root of x to the 4th is just x. The 3rd root of 8 is 2. Now, I don't really know what the 3rd root of x to the 18th is, so what I'm going to do off to the side is I'm going to say, all right, I've got x to the 18th, and I'm going to think about this cube root as a 1/3 power. Now, when I raise a power to another power, what do I get? I get x to the 6th because 18 times 1/3 is 18/3, which is 6th. Another way to think about this is I need 3 groups. If I have 18 x's lined up, I can circle 6 groups of 3. Letter H. I have all of this to the negative 4. Wow. Well, the first thing I'm going to do is switch colors so we can see what's going on. Now I'm going to rewrite all of this because they have common bases, so maybe if I condense this, it'll be a little clearer. So I have x to the 5/3. Then I have x to the 4/3. That's not so bad because now I can add these together and I get x to the 8/3. 9/3, sorry. Ooh, 9/3, that's great because 9/3 is just 3. This problem's getting better already. Well, so now inside this now has become x cubed. So I have x cubed. Now I'm going to deal with that negative 4 power. Well, power to a power I would multiply. That would be negative 12. So my final answer is just going to be 1 over x to the 12th. Let's kind of do the next one the same way. I have every single thing here has a 5th root. I'm noticing here, here, here. So I'm going to kind of ignore those for now. I'm going to ignore my 5th roots, and I'm just going to work with all the a's as they are. So in the denominator, I'm going to leave this a to the 10th. I have 32, and put these together, I've got a to the 15th. If I subtract these, 10 minus 15 would be negative 5, which means this becomes 1 over the 32 stays, and because it's negative 5, it'll be a to the 5th. Now I'm going to put my 5th root back in and think about that. Oop, not 4, 5th. The 5th root of 32 is just 2. So I have 1 over 2, and then the 5th root of a to the 5th is just a. So my answer is 1 over 2a. Looks like 1 over 29. Let's fix it. 2a. Prettier.